Assalamualaikum and good morning to Dr. Muhammad Asri and Dr. Siti Noor Haida. My name is Noor Halily Haida binti Ahmad Hasim and I'm supervised by Dr. Faiz Reza. Today I'm going to present my final year project entitled Feasible Study of Modular Junction Box. The content of my presentation is introduction, problem statement, objectives, literature review, methodology, results and discussion, and conclusion. So what is junction box? A junction box is an electric enclosure used to provide secure environment for electrical wires. It comes in variety of size and shapes. It is made from metal or plastic. It is placed in walls mortar on the ceiling within concrete. It is the main spot for electrical wiring system. The problem statement of my project is when importing big size of junction box, it will cause difficulties during the transferring process from overseas. And it causes higher cost because the big size of junction box consume larger area. So the junction box is proposed to be separated into modules. The objectives of this project is to design a smaller patch of junction box when it is separated and to compare the analysis result of the original junction box and modularized junction box. The scope of this project is focusing only on the underground junction box, and the analysis of junction box will be determined using CATIA software. A bit about literature review is modular design is a design theory and practice that divides a system into smaller parts. It can easily be attached and reattached. Parts will be combined to form a larger and complete system, and it is able to change or swap out broken components to repair without replacing the entire system. So the structure of junction box is grounded junction box, usually made up from high density polyethylene plastic. The method used is injection molding. So the characteristic of HDPE help the junction box to contain any explosion that occurs so that the explosive cannot propagate outside of the enclosure and trigger fire for surrounding atmosphere. The structure of junction box is the wall pattern of junction box is to ensure the condition of the underground junction box so it does not move or shift. A cover of junction box is to secure the container. When measuring junction box, measuring tape and vernier caliper is used because both of them flexible tools. It can be used for hard to reach areas such as corners and curves, and the dimensions was taken in unit millimeter with tolerance 0.01 millimeter. This is the detailed drawing of junction box. This drawing shows top, front, side views and isometry of the model. Next, conceptual design. The design of modularized junction box is proposed. First design is the box will be separated into 6 parts vertically. Bolts and nuts with M10 size will be used to combine the separated parts together. And the second design is the box will be separated into 6 parts horizontally. An addition of steel is located near the wall as slots for the layers of the box to fit in, which means users have to insert the separated box layers by layers. This is the house of quality of this project. So if we look at the rank order, size in part is the most important specification to focus on at 117 or 37.03%. It shows the smaller the size of the brake parts, the easier for user to handle it. So this is the drawing of the original junction box and modularized junction box. We can see that the difference, original junction box only have 2 parts and modularized junction box now have 6 parts. After the drawing has been done, the human analysis was done to visualize the real size of the junction box. In this case, human analysis is done to make sure a dimension taken from original box is the same with the real one so that the correct data analysis can be obtained. Next, we will look at chapter 4 results and discussion. So the static analysis of junction box is made into 3 critical positions, which is first lateral load, second vertical sidewall test, and third cover test. So here figures and table shows the result of displacement of original and modularized junction box. As we can see, for the original junction box, 1/3 of the whole box is having a displacement, while modularized junction box have a smaller part from the whole body that experiencing displacement. We can see that the displacement experienced by the junction box, by the original junction box, is more focused on a place, indicating that the ring point will experience the highest displacement and also affect the surface around it. While for modularized junction box, the area that show the highest displacement, which is red and orange region, are slightly lower than the original junction box. This may be due to modularized junction box being assisted by bolts and nuts mounted at each connection point. Next is von Mises stress. Von Mises stress is used to determine whether the yield occurs in the design or not. If the maximum value of von Mises stress exceeding the value of yield strength of material, the design will experience yielding. The concrete strength is from 10 megapascal to 60 megapascal, while strength for plastic is 8 megapascal. We can see here that the maximum value of von Mises stresses of original junction box is 0.369 megapascal and modularized junction box is 0.308 megapascal. Since both of the von Mises stress value is below the yield strength of which is 10 megapascal, then the yielding will not occur. This indicates that the modularized junction box is reliable. Von Mises stress also are tested at each of the 3 positions. So from the table, we can see that the von Mises stress analysis at all 3 critical points is below than the yield strength of both concrete and plastic. In conclusion, the objective to design a modularized junction box is achieved successfully with a reliable stress value, and the objective to compare the analysis of original junction box and modularized junction box was successfully done. For recommendation, the dimensions of the junction box will be more accurate if we using portable Sense 3D scanner, and from that 3D modeling product can be drawn in Sketch Tracer workbench in CATIA software to make the drawing process easier and accurate. The analysis result can be done more precisely and easier using CATIA, as the analysis of SolidWorks software could not be done in assembly drawing. That's all from me. Thank you.